When you are performing redistribution, it is very possible that you will experience a routing loop. Now, if you just have a single point of redistribution, so one router performing redistribution between two different routing protocols, the likelihood of a routing loop is next to none. However, when you have multiple points of redistribution, as we see here with R5 and R6 in our topology, then it is very, very likely that we could end up with a routing loop. Now, why would we end up with a routing loop? Well, let's say that routing protocol A sends some information into routing protocol B. And routing protocol B sends some information into routing protocol A. Well, that's what we want to happen. But wait a second. What happens if R5 then sends that same information back over, and R6 then sends that same information back over? You see this loop that's happening now? The information that's being exchanged can become corrupt now because we're learning it from the wrong routers, from the wrong domains. And then we could make a bad routing decision. And this all stems from the fact that when we perform redistribution, our routing protocols lose visibility. You see, routing protocols like OSPF and EIGRP, they have built-in loop prevention mechanisms. However, when you start redistributing from OSPF into EIGRP, does EIGRP understand what's happening in the OSPF world? No. Does OSPF understand what's happening in the EIGRP world? No. So what's going on here is this exchange of information could potentially loop back, as we see, and then we have a routing loop within our routing domain. So we have to be able to recognize these issues, and you're going to be able to recognize them based on a few different things. The biggest one being your topology. Look at your topology. Identify those various points within your domain where you could have a routing loop. So you see the topology, you see 2, 3, 4 points of redistribution, and then you can sort of draw some dotted lines, draw some paths, play around with some arrows and see, well, you know, that information could loop back here, it could loop back here, it could go here, it could go there. So that's how you can identify it ahead of time and solve the problem even before it occurs. However, let's say it occurs on the fly in your environment. How are you going to identify a routing loop? Well, you're going to identify routing loops based on the fact that your layer 3 connectivity is going to be broken. Users are going to be complaining that they can't reach particular destination networks. So you issue a ping and then you receive time exceeded messages. The reason why you receive the time exceeded message is because the packet never reaches the destination. So it just keeps going around and around and around and around and around for the amount of time that it takes until the time to live expires in the packet. And then once the time to live expires in the packet, the router that decremented that time to live to 0 sends back a time exceeded message back to the source. So as a result, connectivity never occurs. So it's that final router that decrements the time to live to 0 that says, hey, look, we can't get there, time to live exceeded. Fair enough. You can also identify it with a trace route. When you issue your trace route, you'll see that the path that's being taken all of a sudden just keeps looping back with similar IP addresses. Now, it could be the same IP address going back and forth, back and forth, back and forth, or it might be this IP, this IP, this IP, this IP. Oh, and then it just keeps repeating that particular pattern over and over and over and over again. So how can we solve these issues? Well, number one is to know your topology. Identify it. Be very, very, very familiar with it. But then if you do experience any of these issues, you're going to want to implement route filtering. You're going to use route maps in order to identify certain routes, certain traffic, in order to prevent the particular loops. You'll also be looking at modifying administrative distances, because a lot of times it's the administrative distance that's causing that particular problem that we're experiencing. As we learn about a particular route inbound from another router in the topology, and we make our routing decision based on the information it's provided. Well, what if we learn about that exact same route from another router, but it's a different source of routing information, and we believe that, and it's a lower administrative distance? Now we're using that, but it's actually causing a loop. So we have to be able to recognize those. And then once we do so, modify it with route maps and a whole bunch of other features within that route map that's going to give us the ability to control it, like tagging.